In this, we're just going to review some quick techniques of integration. This first example you see has both x's and y's in it. We can't get a y equals equation, so we're going to have to do the derivative implicitly. So let's start with the derivative of x. The derivative of x is 1. The derivative of sine of y is cosine y dy dx, and remember that's because of chain rule, because we consider y to be a function. So we say this is the inside function. We do the derivative of the outside, leave the inside alone, and then multiply it by the derivative of the inside. So derivative of the outside, leave the inside alone, multiply by the derivative of the inside. On the other side, we've got a product. So first times derivative of the second plus second times derivative of the first. Derivative of the first is just 1. Now I'd like to get all the dy dx stuff on the same side, so let me move the x. Okay, so I'm going to have cosine of y dy dx minus x dy dx. And on the other side, I'm still going to have a y, and I'm going to bring that 1 over to the other side. So I moved the x dy dx, I subtracted that over to the left, and I moved the 1 by subtracting that over to the right. Now I factor a dy dx out, and I'm left with cosine of y minus x equals y minus 1. And I divide both sides by cosine y minus x. Now one thing I just want to mention really briefly is that if you chose to move things differently right here, let's say you chose to move this cosine y dy dx to the right by subtracting it, and then you chose to move the y to the left by subtracting it, so you'd have 1 minus y equals x dy dx minus cosine y dy dx. You then can finish the same way. The only difference is every single sign in your final derivative would be different. You'd have a negative y and a positive 1, and a negative cosine and a positive x. You'd probably have 1 minus y and x minus cosine y. It's the same thing. If all of the signs are different, it's the same. Okay. Next, I would start by rewriting this as 4 multiplied by 5x minus 1 to the negative 1/2. The reason this is going to work so well is because the numerator is a constant. If this were a function, let's say there was like an x here, it was 4x, I would do this then with quotient rule. That we don't really benefit from bringing it up and doing product rule, because product rule will require us to use chain rule with negative exponents. At least with quotient rule, we'll use chain rule, but it will be with positive exponents. So the reason this works so well is because the numerator is a constant. So now 4 multiplied by negative 1/2 is negative 2. All right, dy dx here. Leave the inside alone. We drop the power by 1, so now it's to the negative 3/2, and we multiply by the derivative of the inside, which is 5. So we figure out what's left on top. Negative 2 times 5 is negative 10. 5x plus 1 to the positive 3/2, we put that in the denominator, and that's our derivative.